Hello, this session will be recorded because I cannot do it in the class. So I will try to be short and I will just show you some queries and then you can run them and see how they work. You will find attached file with all the queries which we will see today. So let's start. Okay, so it was planned to be white days, white day, the last day of the week. And let's start from the queries. We already talk about select from group having, that's we already pass. So like that, as you remember, we select the cities which have more than one mention in the our city table. So it's like cities with repeated names. Okay, this is just to remind you that we can use the table from the other database while we are outside of this database. So we can use the name of database. Yeah, here we use it directly, and here we can add it to the name of the table, and the result will be the same. Okay, so here we add one more field, the name, and like that we could check if the city repeated not in all the table, but in the country. So, sorry, we had country code field. Yeah, we already have name here. Yeah, but here we add country code, and like that we will see what's happened inside the country. So not forget to run this query. I will not show it for not lose the time, for make this presentation shorter. So run it by yourself and you will see what's happened. Yeah, you see that we can play here with the alias name. So we can write like that, repeat the count, or we can use the name of the alias which we create here. Okay, both things are possible. They are quite the same. Maybe when you write directly count, it's more visible. So you should not look in the list of the fields what is CNT, because now we have three names in the list, but it can be a lot. Okay, so now we want find the double names, but we won't get the country code, but we want the full list, not just inside one country. We want to repeat the countries, the cities, which repeated in the table with their country code. So what can we do? There's different ways to do it, but here we'll use the inner join with subquery. It's called subquery because, yeah, it's query. We already see it, but here it's like put it inside, and we use it as if it was some table with these two column. So we join it with city name equal to doubles name. So we can get from here, we put in the list double counter, the value of the counter. So we will have name, country code, and how many times this name is repeated in the city table. So this country code will be different for the same name in the different countries. And we order just for it will be easy to watch the results. Here we change our approach. We just use in and we also use subquery, but as you see here, we have just one name. There was two when we join, but when we use in, we can have just one name because you compare this name with this name, and if will be something more fields here, it will break all the structure. So like that, it will not work. It will give you error. You can try. And we still have this count, but we not put it in the output. Here we need it just to uh, select just repeating names. So you see, in that case, we cannot put count in the list. So we will have the same list of names and country code, but we will not know how many times they appears. So maybe this approach is better in that situation. Also, join can be more fast than in. In usually is slower. But all the time when we say that it's slower, it's like expected statistically, but as optimizer works on the queries, so maybe it will be transformed the way that we will not see much difference. And also then our tables are not really big. Maybe it will also, okay, the time will be so short that will be no difference. So we can use not in, we already do it, we already try it. If we want to exclude some cities from the list. And here you see that after all, here it's the same. We can just compare the names and we can use in and use the list. So again, in is relatively slow. So we can expect that in some situation this will be slower, but here when it's free objects, so strings, so it can be okay to write all this condition for all of them. But after some number, it became easier to just put it in the list. And especially because, as we know, this list it can be taken from other tables with some select. So, for example, if you have just two things to compare, maybe better do it that way. Okay, so what's happened if we know that we will need this subquery many times during our session? Then we can do this thing. We can create a table from select, and we can specify engine memory And that's mean that this table will be not created in our database, but it will be created in memory. And it will stay there until our session expired or until the server will be restarted. So if we write some long program and we see that we all the time use this part as subquery, then we can do like that, and it will persist in memory all the time until we're running our code. And then we could use it as normal table, you say. So we create table and it's not depend if it's in memory or it's on the disk, the select will look absolutely the same. Don't know what's happened. Sometimes slides just start move here and there by themselves. Okay, but if we say that we want to keep this data for all time, so we don't want to depend of our session on server restart. If we say that some data is very important, so we will better create normal table like on the disk. Then we can write like that, create table if not exist. So that means if it's already exist, we will do nothing. The name of the table and our select. So you can see that like that we economize the part of creation of a table when we choose the names, when we choose their type and size. And here, like that, the names will be inherited, parameters of these columns will be inherited from this select. So name will be string with the same value of length as in our source table, and this one will be integer. And this table will be created on disk, and we will not depend on some server restart. It will not disappear like table in memory. Maybe again, this could be slower than create table in memory. So when you join and the engine connects to data to the on the disk, it can be slower than when we have data already in memory. But from the other hand, the server can cache the table in memory. So after all, the result will be the same. That's, like I already say, depend on optimizer. And the other approach can be to find the doubles again. That we can join our table with itself. So here you see we in from first we put city as city1 and we join it with city again as city2. And we put a condition that name of the city1 is equal to name of city2, but ID is different. If we not put this condition, then all the records will be at first connected with themselves because they all have the same name, yeah? And it's like two repeated tables connected by name, but when we say that it should be the other record, so ID is different, then we will again get the list of doubles, and also we will see the country code because both tables have this country code. So you see, that's the other way to solve the same problem. Okay, that example we already talked about it. I just repeat that you use asterisk to select all the columns, and if you have two tables, then if you just use it like that, then all the columns from both tables will be selected. You can use it this way. So then you select just fields from country, or you can select the fields just from city. But you should remember that this asterisk is useful things in development because sometimes you don't remember which columns you have, but you should not left it in production because at first it can be a very long list of the columns and maybe they not necessary for your solution. And the other thing is that in time it can change. So imagine now you know that it's like 5 columns in city table and you select them like that and you try to treat them after this data set, knowing that it's contain these columns. But for example, if you delete one column, then this not stop working, but it's return less columns. Or you add one column and also return more columns that you expect. So uh, the worst case, of course, it's when something disappear and you expect that it's there and it will fail on some other steps. So you, for example, send this data to front end and they not get expected columns and it start to fail and okay, it will be hard to see where the problem came from. And if you explicitly put here the list of column which you want to select, then it's mean that if one of these column will be deleted, then this select will fail and you will have clear message where the problem came from. Okay, one more thing which we can do with select. Imagine we want to make the list of all our strings, for example, which we have in our tables, in different tables in the database. So for example, we want to have combine names of country with names of city. So for example, we want to send them all for translation or for some other purpose. So if we do like that, we just select and select, we will have two data sets. And if we join them, it will not help us because we want to have just one columns. But if we join, we will have two different columns. So there's an operator union. Like that, it will union results of this two selects. And we put union all because if we not have all here, it will remove all duplicates. And if we want to keep them, we should put union all. Of course, it can be used with queries with more than one field. Just their structure should be the same. So, for example, here is comparison of two unions. Union all and union. So if you look at this query, so here we like one of the way to do some small report. We use this to have this table as a result. So we add the name of the result, the count, and union it with the other name and the other count. And like that, we can compare that when we use union all, we have more names because the duplicates are there. Okay, so here the illustration how we can use different uh, fields in one union. So not just one column, but multiple. And the other object which we can find in the database, it's a view. So we already have tables. We can write the queries, but imagine that some queries we need multiple times. But we don't want to store their results because they can be huge, first. And second, when you have a lot of changes in the tables, then you need all the time update these results. So view, it's like stored query. So when we create a view, we give it a name and we say which select should be executed when we execute this view. So that will be a result all the time will be dynamic. Why it's also good approach if we have some repeated queries, because as the view is database objects, the database engine somehow knows that it's important thing, and it can see that it can be executed frequently, and it can be optimized already for execution. So for example, it can add some indexes to your data for make this query work faster and so on. So if you have some repeated queries which you execute frequently, it's good idea to create a view. And then you can use this view as a normal table. So from point of view of select, it will be the same as use the table. Okay, so here the other way to manipulate with that data. Sometimes we need to pivot our table. So usually we have like names in the column, some values for them, but sometimes we want to pivot them, so turn them on 90 degrees. So we want to have columns with names which before they have in one row and the numbers which appears behind these names. So for example, here we put count, but inside the count we put if can function. So if country name is Australia, then one, else null. If country name is Andorra, then one, and so on. So what will happen? So this count will count just when the country name is Australia. And in all other cases, it will be null, so it will not calculate this value. And this final count will count total. And we can join country codes. We can join city. Yeah. And like that, here we will count the quantity of the cities in these three countries, and we will ignore all the other countries. So that's a problem with pivoting, because you should manually like create the list of what you finally want to put in the output. And usually the pivoting is happened when you need some reports, because usually it's better to work with columns than with columns name, but sometimes the business people, for example, say, okay, I want it be that way. So usually it's better to do it in some reporting program, which specially created to visualize the data, like for example, Power BI or Tableau. But sometimes we also can do it inside our SQL. Some implementation have special statement for pivoting. For example, in Microsoft SQL Server, there's special pivot statement. But it's very complex. It was all the time hard for me to write it again. It's not happened often, so you try to remember how to do it. You all the time should return to documentation. But okay, it's possible. Okay, so that's the short way to explain uh, what's happened with advanced queries. So finally, after we pass this material, you already know most of the things about how we manipulate with existing data, how we can join them, how we can union them, how we can filter them, and so on. So now you cannot ask me questions, but we will meet on Monday and then we can continue. So thank you very much, and please try to run these queries and to see the result, and maybe even play a bit with them to see how you can modify them. Thank you very much. See you on Monday.